Okay, in this video, we're going to be looking at the graphs of reciprocal functions. Our parent function for this reciprocal function that we're talking about is 1 over x. If we were to look at that as a graph, and again, plug in some points. If I plug in 1, I get 1 because 1 divided by 1. If I plug in 2, I get 1 over 2 or a half. Plug in 3, I get a third. Plug in 4, I get a fourth. You see how it tapers down. If you plug in a half, 1 over a half, flip and multiply, you get 2. Plug 1/4 in, you get 4. So your graph follows that x and y axis as asymptote lines. So let's go ahead and do that part of the graph. And then when you plug in negative values, 1 divided by -1, when you plug in -1 to give you -1. And then you see the same thing happen. When you plug in -2, you get -1/2. When you plug in -3, you get -1/3. When you plug in a -1/2, it gives you -2. When you plug in -1/4, it gives you -4. So you see the same thing happening, and there's a mirror image. There's a rotational symmetry there. So there's a picture of your parent function, y equals 1 over x. The type of graph that this graph is called a hyperbola, which we will deal with a lot later on down the road. Several more of these. The domain, the only restriction, you cannot divide by 0, so therefore your domain x cannot be 0. Okay, now looking at the range of this function, again, notice that you have an asymptote line, that this follows this path right here. It gets closer and closer. However, you're never going to have a y value equal to 0. And the reason for that, if you look at 0 equals 1 over x, y will never be 0. So therefore, you will never have a y value of 0. However, every other y value will be covered. So you have a vertical asymptote at x equals 0, and you have a horizontal asymptote at y equals 0 for this function. Now let's look at the transformation of this standard form. Again, your parent function was 1 over x. However, if you multiply by a, it would change to this. And we know multiplication by fraction or by whole numbers will stretch or compress. So that would stretch or compress it. Then you could put a minus h on that x value, and that would move it right or left. And then you could add a k on the end, and that's going to move it up and down. So therefore, the h would be a horizontal shift. And it would shift it. If it's a positive, it's going to shift it left, as always, because it's on that x. If it's a negative, it will shift it right. The k is going to be a vertical shift because it is not on the x value. If it's a positive, it will shift it up. If it's a negative, it will shift it down. If a is a negative, if anytime you multiply the whole thing by a negative, it's going to flip it. Okay, that's going to flip your function across the, honestly, it doesn't matter because it's going to be the same either way. But we'll say it's a vertical flip. So if a is a negative, the function is flipped across the x-axis. But again, you can test that, and flipping it across the y-axis actually results in the same graph. So you multiply the whole function. Notice I said the whole function by a value of a. That would be a vertical stretch. If it's greater than 0, greater than 1, then that would represent a vertical stretch by a factor of whatever the a value is. If a is between 0 and 1, however, that would be a vertical compression. In addition, the h and k's, think of it like this. If you have like x minus 2 on the bottom, that shifted the whole thing right to, including your asymptote lines, or a value of 2 would make the bottom undefined. You will always have an asymptote line at x equals h, and you will always have a vertical asymptote, horizontal asymptote line at y equals k. So whatever these values are, that's where your asymptote lines will be. And in the original, the parent function, notice there was no plus or minus on the x. There was no plus or minus out here. So that's the reason 0 and 0 were those asymptote lines. First one, writing functions. Number 1 says the reciprocal parent function. So we're dealing with our reciprocal parent. So let's write f of x is equal to 1 over x. And we're going to change it into a new parent function. We're going to reflect it across the x-axis. And the way we reflect it is we put a negative on the whole function. You can put it on top, you can put it on bottom, you can put it out front. But we're going to put a negative on it to reflect it across the x-axis. It is then translated 4 units to the right. To translate it 4 units to the right, we'll put a minus 4 on the x value. We're going to translate it 3 units down, so the whole function is subtracted 3. And that's all that's done, so the top is going to be a 1. There's your new function. Number 2, we again have the reciprocal parent function, so y equals 1 over x. And we're going to transform that into a new function, first by vertically stretching it by a factor of 2. When we multiply by some number, that's what's going to stretch or compress it. So to stretch it by a factor of 2, we're going to multiply the top by 2. Then we're going to translate it 7 units up, so we're going to up 7. And 1 unit to the left, and to go left, that will be a plus 1 on the bottom. There is your new equation. Number 3, same f of x equals 1 over x because it is a reciprocal function. It has a vertical asymptote located at x equals negative 2. So what that means is our entire function, if the vertical asymptote is negative 2, that means it got shifted to the left 2. In order to shift it left 2, we're going to do x plus 2 on the bottom. So there's your vertical asymptote. It has a horizontal asymptote at y equals 5, and all you have to do is put that plus 5 out here because, again, the opposite of this and whatever this value is, those are going to be your two asymptote lines. Write an equation that could represent this function. There is your equation. Okay, on number 4, we're asked to graph this function and then identify the domain, range, and the asymptote lines. We can start out with the domain very easily. We cannot have a value on the bottom of a fraction equal to 0, so therefore x, there's no way it can be 0. That's going to be your domain restriction. Your range restriction, again, this tells you where your vertical asymptote is in this function. So your y value will never be negative 2. So that's your range restriction. And again, those are the two asymptote lines. So therefore, it does ask for asymptotes. So therefore, you will have a vertical asymptote at x equals 0, and you're going to have a horizontal asymptote at y equals negative 2. So I would start out this graph by plotting those or graphing those two asymptote lines. And there those asymptote lines are. Now, I didn't notice these blanks at the bottom. What I would do to graph this is I would do a t-table for my original function. If I plug in 1, I get 1. If I plug in 2, I get 1/2. If I plug in negative 1, I get negative 1. When I plug in negative 2, I get negative 1/2. And then transform those because the only transformation on your graph is down 2 units. So taking those x and y values, we're going to keep the x values the same. The only thing that we're changing is our y values. Again, the transformation was take all your y values and move them down 2. So therefore, what used to be at 1 is now at negative 1. What used to be at 1/2 is at negative 1.5. What used to be at negative 1 is negative 3, and negative 1/2 is negative 2.5. And plot those points. And that's going to give you plenty of points because we know that my graph follows those asymptote lines. So it's going to look something like that. And then the same thing is going to happen over here. Your graph's going to follow these two asymptote lines, and your new graph will look something like that. Okay, the next one, and I'll put these in the blank. First off, your restricted domain value, x cannot be negative 3 because if x were negative 3, again, you would be dividing by 0. The value, okay, well, what value is restricted here? Again, it all depends on where that horizontal asymptote is. And since there's nothing out there, you're going to have a range restriction. Y will never be 0. So therefore, you're going to have a vertical asymptote located at negative 3 and a horizontal asymptote located at that 0. And again, the reason that this will never be 0 is because take this fraction. And there's no way this fraction can be 0 because how can you divide 1 by something to give you a 0? So therefore, that kind of tells you where that range restriction is going to be. So let's go ahead and graph those asymptote lines. And there those asymptote lines are. And here's what I've did. My original y equals 1 over x. There is the t-table for it. And to graph this, all I'm going to have to do is take those original values, and this plus 3 is going to shift them left 3. So that's going to change all of my x values. It's going to take 3 away or move them left 3. So all the y values stay the same. All the x values move left 3. And here those are. And there are those new points. And again, just follow your asymptote lines, and that's going to give you a picture of what your graph now looks like. And there is your new graph. The next one. Number 6. Again, your domain restriction. X will never be 0. So therefore, X is not equal to 0. And that is going to be your vertical asymptote line. And the restricted Y value, a fraction, this will never equal 0. It can't. So therefore, since this can never equal 0, if you take that and you add 1 to it, this whole thing will never equal 1, which is the reason, again, we can say that our range restriction, we can just look right out here at this plus 1. So therefore, our range restriction, y will never be 1, and that's going to be your horizontal asymptote. Again, whatever the bottom plus or minus down here, and whatever this number is, that's going to be your horizontal and your vertical asymptote. So let's plot those and start making us a t-table. And there is your t-table for your parent function, y equals 1 over x. Now let's identify all transformations. This is going to do two different things. It's going to stretch your y value by 4, so that's going to be a vertical stretch, or we'll call it a y stretch, times 4. And it will also, because of the negative, reflect it vertically. So it's going to be a reflection across the x-axis. And if you remember correctly, what that's going to do is it's simply going to change your y value of positive 3 to negative 3. That's it. And then the last thing is we're going to take our function, and because of the plus 1, we're going to move it up 1. So in this issue, or in this problem, the y value is the only thing that changes. All the x value, because we're going to multiply the y by 4 here. We're going to change the y value to a negative, and then we're going to move the y value up 1. So all the x values stay the same. And then the y values, the first thing we're going to do is multiply by 4, and then we're going to reflect it by making it negative. So multiply by 4 makes this a 2, and then make it negative. Multiply by 4, make it negative. Multiply by 4, make it negative. Multiply by 4, it gives you a negative 2, and then make that negative as a positive. Multiply by 4, make it negative, it'll be a positive 4. Multiply by 4, make it negative, be an 8. Then we have to take all those values, and we've got to move them up 1. So therefore, I can just do me another column right here if you'd like to. And that's going to be a negative 1, a negative 3, negative 7, 3, 5, and 9. And that's going to be my new y values. Now let's plot those and see what our new graph looks like. And there's a picture of my new graph. Now you can even, instead of using transformations, and we might do this on the next one, you don't have to use transformations to graph this. You kind of know the general look of it. You can plug in, like here, to get some more points, I plugged in 4 into my actual function, and it gave me some really easy points. I plugged in negative 4. It gave me an easy point just because it was easy to plug those in. 2 would have been easy just to plug in. Okay, number 7. And on this one, we will identify our asymptote lines. Our domain restrictions is going to be x can't be 2 because of the division by 2 here. And since this fraction will never be 0, the whole function will never be negative 2. So therefore, you have a vertical asymptote at 2, and you will have a horizontal asymptote at negative 2. Let's go ahead and graph those two asymptote lines. And there you see them. And again, instead of actually doing our transformations here, if you would like to, just plug in some points. Plug in an x value of 3. Gives you 3 minus 2 on bottom. That's 3 over 1 minus 2, which would be 3 minus 2, which is 1. So when I plug in 3, it gives me 1. When I plug in 4, it gives me 3 over 2 minus 2. That's 1.5 minus 2. That's negative 1/2. So when I plug in 4, I get negative 1/2, which is about right here. And again, you can already see, you already know that this graph is going to follow asymptote lines, so you kind of have the general idea of the graph just from a couple of points. Now, in order to find the points on the other side of this asymptote line, let's plug in points like 1. So now you have 3 over 1 minus 2 is negative 1. That'll be a negative 3 minus 2, which is a negative 5. When I plug in 1, I get a negative 1, 2, 3, 4, 5, which is right in there. When I plug in a negative 2, I'll get 3 over. Negative 2 minus 2 is a negative 4. Subtract 2. So that would be negative 3/4 minus 2, which is negative 2 and 3/4. So when I plug in negative 2, which I'm not sure why I plugged in negative 2, 0 would have been much easier. When I plug in negative 2, I get negative 1, 2, and 3/4. And let's plug in some points in between there. Again, 0 would have been the easiest. When I plug in 0, you get 0 minus 2, so that'd be 3 over negative 2 minus 2. That's negative 1.5 minus 2, which is negative 3.5. So 0, negative 1, 2, 3.5. I believe it's right there. And again, that is simply going to follow this asymptote line. So just draw you some lines, connect, and follow the asymptote lines, and there's your graph. Number 8. Again, identify your domain restrictions. X can't be negative 4. And your range value will never be this, so Y cannot be negative 7. So you have a vertical asymptote at negative 4 and a horizontal Y equals negative 7. Let's plot those. And honestly, from here on out, you could actually just plug in some easy values. Again, what I mean by easy, something that's going to be divisible. Think of it, always think ahead when you're graphing. I've got to do 2 divided by something. Think of some things that's easy to divide by, 2 divided by. Like negative, when I plug in negative 3, notice the bottom is now 1. So I have 2 divided by 1 minus 7, which gives me negative 5. So again, think of things that would be easy to plug in. So negative 1, 2, 3, 1, 2, 3, 4, 5. And honestly, that's enough points on that side of the asymptote line to graph. And then plug something else in like a negative 5. And notice what that does. That puts a negative 1 on bottom. So 2 divided by negative 1 is a negative 2 minus 7, which is a negative 9. So when I plug in negative 5, I get a, let's see, that would be negative 5. I'll get a negative 9, which is here. Then from there on out, we will again just follow our asymptote lines because they are guides showing us where our graph's going to go. And you have a picture of your graph. There you go. Number 9. Again, you have a domain restriction of 5, so x will never be 5. So therefore, that's going to be a vertical asymptote here. Your y restriction, y will never be 3. So therefore, that's your range restriction. Y will be everything else but 3. That'll be your horizontal asymptote. Again, let's plot those 2 asymptote lines. And again, plug in some points close to those asymptote lines. Like I would plug in maybe a 6. That would give you, on a t-table, plugging in 6 would be negative 1 over 1 plus 3, which would be 2. So when I plug in 6, I get 2. When I plug in something on maybe the other side, like a 4, I get a negative 1 over a negative 1 plus 3. That'll be 1 plus 3, which gives you a 4. So when I plug in 1, 2, 3, 4, I get 1, 2, 3. And this graph looks a little bit different. And the reason, again, that it looks a little bit different is because of that negative sign on top. Remember that a negative sign is going to flip it, and that's the reason that this is flipped compared to where it normally is. And there's your graph.